Hello and welcome back to Cracking the Cryptic, and unsurprisingly, Jovial's video of how to set a really interesting Sudoku has been getting a lot of praise, a lot of views, a lot of interest, and that's on the main channel. Was posted yesterday morning. Really interesting video. We're so grateful, and I see that other setters are thinking of sending us videos as well, so this could be a really interesting series in some ways. Very looking at it from the other side very much, and working out how much effort goes to setting some of these amazing puzzles. Now today's is a puzzle by Sa, who I think possibly prefers to be known as RSP, but we've been calling him Sa for a long time, and it is part of his name at least. So this one is called Decipede. It was part of the Creepy Crawly prompt from about a month ago on the Discord server, and we've done some very interesting puzzles from that. I think this is a Decipede because it has 10 legs effectively down the sides, but the rule set is very simple. This is a little killer Sudoku, so normal Sudoku rules apply, and along the marked diagonals, the totals are given. So that diagonal adds up to 40. It can have repeated digits. Indeed, I think the number 40 would have to. Yeah. And there we go. So I looked up Decipede. I wasn't sure if there was such an insect. Apparently only in the world of StarCraft or video games is there an actual Decipede insect. Of course, it could be a decapod, which is a squid or something like that, I guess. There must be various other ones, but Decipede is the name of this puzzle. Anyway, just before I get started, I will quickly mention the apps and Patreon, where there is so much intriguing content, especially at the moment. Do consider subscribing to the channel, joining Patreon, buying the apps, all on the links in the description field. Obviously, you can just hit the subscribe button. Anyway, let's get cracking with this puzzle. Yesterday, I had an absolute disaster and a bit cumbersome about the break-in, and then failed to spot a blatant knight's move for the whole puzzle. So let's hope I'm on better form today. Right, first digits in instantly because of these one-cell clues, and this one is 20 and can't have a 9. Now I know from doing Killer and Kakuro and the like, that must be 875. That one can't be a 5. 17 here is not so obvious. There's quite a few possibilities. I mean, as always, when you just have little killers, some of them are likely to provide useful break-ins, unless it's one of those puzzles where you get a huge diamond and you can balance it off against itself. Oh, this 40 is good. Yes, this can only, the maximum this can be now is a 6, which I'm going to write in because I can work out that these other two pairs of digits must both be 9 8s. 17 plus 17 plus 6 is 40, so that is its absolute maximum number. And indeed, we know that 8s go on the perimeter because of that 9, and the 9s go on the anti-perimeter. Is that what it's called? I don't know. This has become a 7. Oh, we've got a real start here. This isn't bad at all. I hope this puzzle keeps going like that, and I bet it won't. Now, finding the right clues. Look at this 20 down here, lurking there at the bottom. Tiny number. Now, the absolute minimum you can get on a long diagonal is 18, because 1, 2, 3 in each box gives you 6 times 3 is 18. Here, this is not 1, 2, 3, and 1, 2, 5, which is the minimum once you have a 5 in, is going to give us our 20 diagonal. So we've got 2, 1, 2, 3 triples, a 1, 2 pair, and a 5. That adds up to 20. What's this? We've got 23 on it already. Oh, this could be 4, 5, 1. And then this could be anywhere between 6 and 9, which is 4 degrees of freedom. Well, sorry, it's 3 degrees of freedom above 6. Oh, that's not so helpful. I mean, I suppose those numbers can't be above 6 because 6, 2, 1 is the only way you'd get a 6 in them. That's not really useful pencil marking, I imagine. It's 40. Max, oh, this could be a 7. 14, 23, 26, 43. Ooh, the maximum is currently 52. The minimum is 16, 1, 1, 17, 18, 1 and 2, 21 and a 1. 20. Must have got that wrong. 17, 18, no, 22. Okay, that is a useless clue at the moment. What about this? Oh, 18's got an 8 in it. Right, so the minimums now are going to get interesting. 1 and 2 here. That's 3, plus that is 4, plus that is 12. Then we'd need 6 more. This is not obvious to me. What about this 17? I looked at that early on. Oh, I've got a 1 or a 2 on it now. So the most this can be is 6. And that'll do it. That's a maximum now. 6, 2, 9. So we get the 1 there. So that can't be 1 or 6. That can't be 2. And this can't be 5. I'm not sure this is going to help me at all. Now the 18's got a minimum number on it. This, though, 1, 2 there, 3, 4, 12. This could still be up to 6. Oh, hang on, no. Look, 6, 5 pairs. So that's a 5, 6 pair. Now it's getting interesting. 8, 13, 14. The most these can add up to is 4. Ooh, what happened there? So that can't be 2. They could be 1 and 3 in either order, or 2 and 1. Maybe it is going to be worth colouring the 1, 2, 3 numbers. I don't know. I just have a feeling. We haven't got any triples yet. 2 of these are going to have to be from 1, 2 and 3. Oh, and these can't... Oh, I knew those couldn't be anyway. Okay, this is a 9-8 pair. I can see 9 and 8 up here. Oh, that's an 8, an actual number that goes in not on one of the diagonals. That's quite interesting. So that's 3 or 4. We've got 3, 4 or 7 to go in here. 1 must be in one of those two. So 2 must be in one of those two, and 1 isn't. Okay. So 3 of these will turn blue in due course. I don't see how to tell which. Is there any regular Sudoku we can do further down the grid? Seems... Oh, look at 8s in the middle box. That's fabulous. Yeah. That's a really neat touch. Where does 8 go in this middle box? Not in the yellow cells. Now that still leaves us 2 possible places, but it's put 8 on this diagonal. And I have a feeling 9, 8, 6 is 23. 8, 4, 1 is the minimum, which is 13. That's 36, and this becomes 1, 2, 3. That is hella gorgeous. I mean, that is really clever. So these are 1, 2, and 3. This is 8 and 4. That's what it has to be. And this is a 1 in the middle. Absolute minimums now, given the 8 in one of those. That's so elegant. I'm going to put in the 5, 6, 7, 9 possibilities. Ah, so clever. 7, 16, 18. Oh, this 40 was Impossible earlier, even with 7 and 9 on it. Okay, let's just have a look at maximums. 7 there, 14, 23, 26. 2 and 4 maybe, 32. That's not maximums, that's minimums. I'm getting mixed up. 7, 9, 7 is 23 and 3 is 26. 9 and, oh, they can't be 8s. 9 and 7 would be 42 and 8. Oh, 50. That's not good. I don't think the minimums are going to be any better. 7, 9, 2, 2. That's 20. 2 and 4 there, 26, and a 4 is 30. No, that 40 was no use. Let's have a look at the 28. Which has now got... Okay, let's have a look at minimums here. Actually, I'm going to pencil mark them in. 4 there. I suppose 1 and 2. Why not? 4 there. 2 there. What does this lot add up to? 4, 7, 9, 13. A 5 there, 18, and a 6, 24. So it's 4 degrees of freedom. Which means if that was an 8, everything else would have to be absolute minimum. Is that right? 4, 1 and 2 is 7, 11, 13, 18, 24. Yes. Can that be an 8? Everything else would be its utter minimum. I can't see why not. That's annoying. Okay, I'll have to come back to the... It could be an 8. It would be incredibly helpful if it was an 8. If this was the minimum, it doesn't really affect that 40. Oh, what about this? No, that can't be a 1 now. Oh, it's a 1-3 pair. Looking at that, that becomes a 4. That's pretty as well. Took me a while to spot that. We can take 3 out of there. We can take 4 out of here. 2, 3 are looking at that, which becomes a 1, which ping-pongs back to that 3, and a 1 there, and a 2 there, and a 1 there. That's amazing. Oh, this is a 3. That's a 2. These aren't resolved, or this. That is so brilliant. Just from a 1-3 pair in column 2. That all fills in like that. This is not a 1 now. In fact, it's not a 1, 2, or 3. So this can't be 8 anymore. I'm pretty sure about that. This is indeed... I think I've reduced these to 2 degrees of freedom. So let's take out the corner marks. Because they were just placeholders, effectively. I think... Let me just fill in the 2 degrees of freedom that I believe... for every cell, I reckon, as well. This, I think that has to be a 2. I'll just leave that like that for now. This one, I'm almost certainly going to make a 4 any moment. 2 or 3 there. Right, so the minimums 4, 8, 10, 14, 16, 21, 27. There's only 1 degree of freedom. That is definitely a 4. Since this can't be a 3, it is a 2. That can't be a 5. Sorry, I didn't see that. So I've got 3 cells left, and only one of them is the higher number. The other 2 have to be lower. That 2 sees this 3. Let's keep going with the shading of 1, 2, 3s. Another one there. There's a lot done. Oh, that's lovely as well. This cell is 5, 6, 7, or 9. Now, I wouldn't normally think a 4 candidate cell helped, but look at that quadruple. 5, 6, 7, 9. Now, I actually noticed that by realizing that this cell is seen by 1, 2, and 3. Therefore, it can't be 1, 2, or 3. So 5, 6, 7, 9. We've got 2, 3, and 4 to go in there and there. This can't be 2. But this can be, irritatingly. Still can't resolve that 2 and 3. Now, what about... So I've still got this... Oh, this 18 diagonal. I've only got 1 cell left to fill. So I can do that by adding it up. 5 there. That didn't help with these. Still, one of them is going to be higher than the minimum. 6 has come out of those. Oh, for the 4 there gave me an 8 here long ago. Got it finally. Don't think it was helping before. 8 in one of those 2 cells. Five, 6, 7, 9 seems quite an interesting set. I've now got 3 of them in this row, but 4 can go in either of those places, I think. Now, come on. This and this add up to, let me just check it again, 10, 19, 21, they add up to 7. So it's either 5 and 2 or 4 and 3. I don't know. Oh, where does 4 go in this row? We've got 4 and 7 to place. So 4 goes there, 7 goes there. These are blue. They are 1, 2, or 3. This, I just don't think this is helpful yet. 16 at the maximum, 3 and 3 is 22. Then you could have 9 and 7 is 38. And 8 there, 46. Still 6 degrees of freedom from the maximum, and the minimum 7, 9, 2, 2, 2, 4, 5. 7, 9, 2, 2, 4, 5 is 29, and 6 is 35. It's not, it's getting tighter, but it's not fixing it. Really isn't. Okay, so I need to do a bit more. Maybe I'm just missing something. 7, we've got, oh, that's a naked single 5 because of the 8, 9 pair, oh, in its box. Oh, well, that fixes that 7. That's 3 or 6. This is 3 or 8. This is just by candidates remaining based on what it can see. 2, 6, or 8 there. Oh, come on. Still haven't done that 2, 3 pair. That's really surprising. 1 is in one of those 2 cells down here. 3 is somewhere along the bottom, and 2 is somewhere in there. So one of these is blue. And the other one is 4. What's that telling me? Not enough. Oh, that's not a 5 because of that 5. Ah, that's been there for ages. I am having another bad one. So this becomes a 3, doesn't it? Let's just check that. 6, 5, 4, 3, 2, 28. Yes. Okay. So they're not 3s. That's a 3. That's a 2. This is 6 or 7. Now we can place 4 in this row. 5, 9, 2, 4, 8. That is a naked single 1. 3, 6, or 7 there. Let's color it because it's a 1. Still haven't done this 2 and 3. This is now 2 and 4 down here though. 2, 4. So I'm going to color it again. I don't really know that this coloring's had any effect on the solve. 5, 6, and 7 to go in here. This one in column 9 can't be a 5. This is such a clever puzzle. 4, the last 4 in the grid, perhaps? Going in there. Oh, that 3 is seeing this cell. That is seeing the 8 there. 2, 3, and 6. 2, 6 and 8. Oh, that's 2 or 6 as well. Oh, well, that's going to help a lot of things. So we get an 8 here. These can't be 6 now. So we've got a 5, 7, 9 triple here, and then a 2. So that can't be 7. So this is 7. That's quite nice. Those aren't, and that's not 7. That's a 3, 6 pair, so I can do that as a 7. Get rid of 7 out of those two. These can't be 8, so 8 in the row is in one of these two. Oh, that's now 4 and 1. They're resolved. Still haven't done this pair. And I must have a kind of offsetting pair of blue cells to come in down here. Right, let's pencil mark everything, I think, now. See what we've got. 2, 5, 7 and 9 to go in the column. That one can't be 7. In 5, 4, that can't be 5, and this can't be 9. That's not a helpful triple yet. 8, 2, 3, 4, 9, 7. So 1, 5 or 6 there. Oh, all of the possibilities here. 4, 3, 2, 1, 7, 9, 5, 6 and 8 there. This box 8 is definitely the most recalcitrant box available. 3, 6, 7 and 9, and this 1, 4, 2, 9, 7, 3, 5, 6 and 8. Now what am I not seeing here? Oh, diagonals. Oh God, yes, right. 24, 28, 31. These two have to add up to 9, and that one is odd. Is it? Or can it be a 6? No, it can't be a 6. So it is 7 and 2. And we finally got that pair done. Does that fix my 3 and my... The 2 fixes the 1, 2. That gives me the last 1 in the grid. Let's do the last bit of colouring that I will be doing. That can't be 1 anymore. This can't be 3. Are we finished now? No. But we've done all of the diagonals. All the little killer clues are done. How is this not resolved? That's an X-wing on 6s. One of them has a 2, one has a 3. This can't be 7 anymore. Ah, 5, 9 pair. So this is 7. Yeah, that works. So that's not, and that's not. Oh. What on earth? 5, 6, 8, 9. Oh no, look, 6 in the row has to be in one of those two cells, so those can't be 6. Eight? No, 8's in one of those, but it doesn't really do anything. Oh my goodness, what am I missing here? Wow, this is really weird. 6, 9 pair, 7 there. Sorry, that is the last 7. Oh, that doesn't resolve anything else. Oh, that's interesting. This is a sort of bent Y-wing or something, I think. This cell here, if this is a 6, that becomes a 9 and this becomes a 5. So if that's a 6, this is a 5. If it's a 9, That's a 6. That's a 5. Oh no, that doesn't do what I thought. Sorry. Is there something that... Oh, what am I missing here? I mean, I could say that that can't be 5, 6 because of uniqueness, but I'm not going to do that. Oh, no, that's quite interesting. Right. If this is a 9, then that's a 6. Then that's a 9. Then that's a 5. So if this is a 9, that's a 5. But otherwise, this is a 5. So one of those two is a 5, and that one is not. That's crazy. I'm sure it doesn't need to be that complicated to figure that last step. I'm quite pleased with that, though. I'm assuming it's a last step. We've got... Yeah, that 9 has sorted out that. That resolves this 6-9 pair. The 6 resolves this 5-6 pair. 8-9 has been done. That's a 5. That's 6. That's 8. This is 6. That's 9. Oh, this 2-6 pair has been done for ages. I didn't need all the complicated stuff at all, I suspect. There we go, anyway. Resolved. What a lovely puzzle. That's so clever. Really neat. I felt got a little bit better at this one than yesterday. Ooh. Ooh, there you go. And there. Not so good at the colouring. Look at that. Loads of colouring. There we go. All done now. Let's check. Okay. And brilliant puzzle. I mean, just a little killer, but really a tough one. 10 legs indeed. So thank you very much for watching, as always, and very much hope to see you again soon on the channel. Bye for now.